Hey folks, and welcome back to the Project Nebby channel. If you've ever wondered how to create a live interactive AI agent, then this video is for you. So I'm going to be guiding you through coding several of the most critical modules needed for a working AI agent conversation pipeline. The first video in the series starts with the speech-to-text module, and in future videos, we'll go over the large language model and the text-to-speech modules. I've designed this tutorial series to be fairly simple and easy to reproduce, so there aren't any strict hardware requirements. As long as you've got a fairly modern device, you should be just fine with this tutorial series. And if this sounds interesting to you, please like and subscribe so that you don't miss out on the other videos. Now before we begin, let's have a look at what the completed tutorial script does. So let's run the script now. As you can see, as soon as I start speaking, the voice activity detection picks up my speech and starts recording. Then as soon as I stop speaking, the recording is transcribed into text in real time. Okay, now the first thing to do is to set up your Python environment. You can use Conda or virtual environments, it really doesn't matter. If you haven't got Python, feel free to search online for other videos which go over the Python installation process and then come back to this video. Now, if you've got Conda set up on your device like mine, then you can create a new environment for the tutorial series. Let's call this the tutorial environment with Python version, say 3.11, and we're also going to need PyAudio. And now what PyAudio is it's a package that's useful for the audio capture for this project. And the installation instructions for PyAudio are slightly different between Windows or macOS or Linux. So for example, in macOS, you're going to need to make sure that you install port audio first. So ensure that you do that, and then you can run the environment creation. Make sure that you press Y to complete the environment creation. Okay, at this point, make sure that you activate your environment. And then from here, we're going to install two more modules to help us on this project. The first is the speech recognition module, and this is going to help us with the transcription. And the second module that we're going to need is the voice activity detector using a Celero VAD. So this will help us determine whether someone is speaking within an audio chunk. So from here, all you need to do is just pip install both modules. Okay, now that that's done, let's clear the terminal and let's start writing our script. Okay, so the first thing that we'll do is set up the structure for our script. Let's create a class object which we'll call recording, and an initialization method, which we won't do anything with for now. But then if we run this script, whoops, then we will make sure that we initialize the recording object. Recording object. And then let's just remind ourselves that this is how you stop the recording. And then put an exception for keyboard interrupt. Okay, now from here, let's make sure that we import our packages. So the first package that we're going to need is PyAudio, And then from here we will want the speech recognition package as well. Let's call it SR for short. And then we will want our voice activity detection. Okay, so in the initialization method, we're going to create our audio object, or a Pi audio object. And also our voice activity detection object. And also our recognizer from the speech recognition module. All right, from here what we need to do now is instantiate a Pi audio stream. So let's say self audio open. And then if you know anything about how Pi audio works, you're going to need to define your format, the number of channels for your stream, whether it's an input stream or an output stream, and also the rate at which you're capturing audio, and as well as the size of the audio chunk. So let's put these static variables here. So let's say the format is, oops. And for these static variables, it's probably best to just copy what I have here. We're going to do a mono channel at a rate of 16,000 hertz. The chunk size will need to be 512, and this is just because that's what the voice activity detector is expecting. Okay, so let's pass in these variables. And this is going to be an input stream because we're going to record from this. And I think the last variable is frames per buffer. All right, nice. Okay, let's start writing our second method. Let's call this listen for speech. And when this starts, let's say listening for speech. And we'll have this running in a loop. Okay, let's start by reading from the input stream. Number of frames would be equal to the chunk size. At this point, we're going to need a new method to check whether something is silence or not silence. So we're going to make use of the voice activity detection. So we're going to return using the voice activity detection that we defined earlier. We're going to take in the data that we pass into this method, and let's define some threshold. Let's say threshold is going to be 0.5. This is some probability that speech is detected within that chunk. Okay, so from here, let's say if it's not silence, print some speech is detected. Now, if we actually run this method, so perhaps here, for example, we'll do listen for speech, and then let's try running this script right now. All right, now we can test, and we can see that as soon as we start speaking, it will say speech detected. And just to make that even clearer, if I cancel this here, and then just put here we say speech, let's say speech not detected. And then we can run our program again. Hello, hello. hello, hello. You can see that it detects our speech as soon as we start speaking, and when we stop speaking, then it'll say speech is not detected. Okay, now let's make our terminal a little bit smaller so we can see more of our code. Zoom out a little bit. All right, so from here, we're going to want to enter into a new loop. Let's say once we do detect speech, we're going to enter into a new loop to record the audio. And let's give this a variable called silent chunks. And this will also start with while true, just for now. It will read the data from the stream. And let's just create new frames here. Just append the data into frames. And then once silence is detected, let's start increasing the number of silent chunks. And otherwise, we'll put this number of silent chunks back to 0. And the idea behind this is that we want to see consecutive silent chunks. And if there's enough number of consecutive silent chunks, then we're going to end the recording and we'll break through out of this loop. So we can say if, let's define a silence duration. Let's call this, say 0.5 seconds. This is seconds. In order to calculate the number of seconds, we just have to type here if the number of silent chunks greater than, let's find the integer, will be the rate divided by the chunk times the silence duration here. Then we're going to say silence detected, stop the recording. And at this point we can say, we can remove this part, and we can say speech detected, starting recording. And then we'll run the record audio here. Okay, now let's test how this does. Remove that colon there. Hello, hello. Okay, I forgot to break out of the loop. So we should add that. Let's try that again. Hello, hello. And what it'll do is it'll go back to listening, and it'll only record when we're speaking. Okay, very good. That's all working. Okay, now you're going to notice that there's some issue here, and that's because the audio doesn't capture any pre-speech buffer. What this could manifest as is that once you start the transcription, it could potentially cut off the first word that you say. So what we want to do is we want to take in a new input called the pre-speech buffer. And instead of initializing a new list for the frames, let's just copy the pre-speech buffer. And then we're going to initialize the pre-speech buffer here at the listening method. And we're going to determine a new static variable here, which will be the pre-speech buffer duration. Let's also make this 0.5 seconds. Just comment here, this is the probability. Okay, so the duration of the number of chunks at least would be an integer here. It would be the duration, or just do rate divided by chunk times the pre-speech buffer duration. Okay, and as we read in the data, we're going to want to append this data into the pre-speech buffer. And we don't want all of we don't want all of the data to be present in the pre-speech buffer, so we want to keep this list the length of the number of chunks here. So we want to do if the length of the pre-speech buffer is greater than the number of pre-speech chunks that we determined earlier, then we want to pop the first element out at index 0. Okay, and so we want to pass the pre-speech buffer here. Okay, and now if we test our code again, there wouldn't be any change. It's not going to be noticeable right now until we start writing our transcription method. But yeah, it still behaves just as it used to. Okay, at this point we're going to write our transcription method. So let's start a new method called transcribe. Let's take in the audio frames. And now if you know about the speech recognition module, which we've imported here, it will perform the transcription over its own audio data object. So we want to determine our audio, we want to initialize our audio data object here. And then we're going to join these bytes together that are in this frames object that we pass in. And we're going to pass in the rate and also the sample size. So this is from our PyAudio object. And then we're going to try the transcription using the recognizer. And for now, just to make sure that everyone's able to use this, there's a number of different methods to use within the recognizer object, and you can read the documentation for that. But just for now, to make sure that everyone can use this properly, we're going to use the Google Translate transcription. So we will say the transcription is this one. And then it's possible that the recognizer can throw some errors, so we will define what to do. We'll catch those errors and define what we do in those cases. Say that this is going to be what happens if you have no connection to the service, for example. I think in this case, maybe instead of printing here, I'll just return like so. And then no matter what happens here, we want to do print transcribe and pass in the frames to this object. All right, now if we run this, let's have a look. And now we'll test if the transcription works. And it looks like, yep, it looks like it's working. And there we go, we have a little bit of a live transcription going on here. Now you notice that this is not the fastest method to get a transcription because we're using Google Translate. But as part of the speech recognition package, you can also use a local whisper or an API whisper, and you'll get results much quicker than with this method. Just to show you real quick that there are a large list of possible recognizers here that you can use, including OpenAI Whisper, which works offline, as well as some online versions of Whisper. And in order to see what recognizers are available, you can take a look at the speech recognition package here. Okay, but before we move on, I'm going to try to do a different version of the speech or the text-to-speech module, which will run in the background. So currently, as we run this, you can notice that it's actually a blocking program because it's got the while true loop and it runs on a single thread in a blocking fashion. But for various projects, you might want to have your AI agent be able to listen in the background while you also do something else. So we're going to try programming that version. And in that case, we're actually going to make full use of the speech recognition package because it's got a listen in background method that we can take advantage of. But we did this method first because it's a little bit more instructive and a little bit more customizable. Okay, so let's create a new file. Let's call it TTS background. Once again, we import the speech recognition package. And we're going to make the recording object again. Once again, from here, we're going to run something. To try the recording. And then this time, to make sure that is non-blocking, we're going to put in while true. Of course, we need to import the time package here. And we'll pass an exception for keyboard interrupt. Okay, this time we want the recognizer again. And if we're going to record with the speech recognition module, we have to pass in the microphone object. Okay, and so when we initialize the mic, let's also correct for the ambient noise. For ambient noise. Next, we're going to define the listen in background function. And this one we can use, we can take full advantage of the recognizer listen in background. Oop. And we're going to need a callback function as well. So let's call this as transcription callback, and this will not be defined for now. But let's try defining it now. Self and okay, let's do that. And just for completion, let's make sure that we initialize the listener object here. And we'll do a stop listening function. So if we've started up the listener, then we're going to wait for stop is false. So we'll just stop the listener, and at the exiting here, I'm going to make sure that we stop listening. Okay, and we're going to use the recognizer in the callback function in order to print the transcription. So this will be essentially the same thing as before. So go back to our old file and go to our transcription. Remove this pass here. All right, let's paste that there. So instead of SR audio, let's just put audio. And we don't need to use the self-recognizer here. And in this case, we don't want this to return anything, so we'll just have it print each of these statements. I'm missing a quotation here. We're missing F there. Okay. All right, now let's give this a try. Hello, hello, this is the running in background example. Okay, I just noticed the silly mistake in that we had never actually started listening for speech here. And now we can try that again. Hello, hello, this is running in background. Yes, so indeed, your main program can actually be doing something else while your text-to-speech is running. And the transcription from the Google Translate is not necessarily the most accurate, but if you change to Whisper, for example, and maybe if you spoke a little bit louder and enunciated a little better, then you should be able to get a more accurate transcription. But yes, indeed, so this works perfectly fine for most projects. Okay, so I hope this was a very interesting and educational tutorial for all of you. And let me know if you want to see more of these kinds of videos. I am planning a bit of a tutorial series for some of the other modules involved with making an AI agent that has a live conversation capability. Hope all of you folks have a very nice day, and please like and subscribe if you'd like to see more, and take care, y'all.